Let's start by looking at how these AI models work and how they are created. How do they know what a bear or a farmer looks like? They know because they have that information encoded inside a latent space. A latent space is simply a multidimensional representation of compressed data. And this latent space is created by training the model on a huge number of image caption pairs. When the AI has seen thousands of images of a concept, it creates a representation of what it thinks that concept should look like. It is similar to the mental models you have of the different things you have seen throughout your life. You might classify things by color, shape, size, but the AI extracts the characteristics that things that are most adequate to classify the concepts in a way that it's easy for it to then know which thing is which. We might not even have words for these characteristics. Let's look at an example. In order for the AI to understand that this image is a banana and this image is a balloon, it looks for metrics that help separate these images in the latent space. So how about color? If we measure the amount of yellow in the image, that would put the banana over here and the balloon over here, in this one-dimensional space. But then, what if we run into this? Now, our yellowness metric isn't very good at separating bananas from balloons. We need a different variable. Let's add an axis for roundness. Now, we've got a two-dimensional space with the round balloons up here and the banana over there. But if we look at more data, we may come across a banana that's pretty round, and a balloon that isn't. So maybe there's some way to measure shininess. Balloons usually have a shiny spot. Now we have a three-dimensional space, and ideally, when we get a new image, we can measure the three variables and whether it falls in the banana region or the balloon region of the space. But what if we want our model to recognize not just bananas and balloons, but all these other things? Yellowness, roundness, and shininess don't capture what's distinct about these objects. That's what deep learning algorithms do as they go through all the training data. They find variables that help improve their performance on the task, and in the process they build a mathematical space with way more than 3 dimensions. Any point in this space can be thought of as a recipe for a possible image. The text prompt is what navigates us to that location. But then, there's one more step. Translating a point in that mathematical space into an actual image involves a generative process called diffusion. The diffusion step is similar to how we turn the concepts that we have in our heads to a drawing, just done by a computer.